Hello, today we will talk about the views, and we will use the same example database as earlier with the car and owner and postal address. A view is a definition that gives us a filtered view to a part of the database. You can say that we can make a kind of tailored table. And a view represents a selection of columns from one or more tables. And that can, for instance, be more practical than in a query having to join a lot of tables, when you can instead make a query against one view. And a view can also improve the security, because by giving access to the view instead of all the underlying tables and data, the user will have access only to the part of the database that he or she really needs. And when we have created a view, then in queries, views can be joined with other tables just as if they were real tables. But the view is a definition of a table structure and not a real table. You can say that it is a kind of stored query where the result can be handled as if it were a table. Another advantage is that a view definition will only execute when it's needed, and therefore it uses only a little storage. And now we will have a look at some practical examples. In this example, we will use the same tables used in the previous videos. So here we have the car table, and let's say that someone in the company needs to make some statistics about the sold car makes and their prices, etc., but that they don't need access to the reg number and owner ID. Then we can create a view and give the user access to that view. So what we want here is to extract this part with the 4 columns: car make, color, reg date and price, and make that a view. And to make a view, we start just like we do when we create a table. We write create view and give it a name. And now I name it sold cars all, to list all the cars that are sold. And then the keyword as, and we can then define our view, which we do with a select sentence. So just as we have learned basic SQL earlier, we write select and list the columns that we want to be part of the view: car make, color, reg date and price, and we tell that these columns will be retrieved from the table named car. Then I go to the car owner database in SQL Server, and we select a new query window, and we can run this query. Execute, and it completed successfully. So I can go to car owner database, and if I go to views and I have to select it and click the F5 button to refresh it, then we will see the view that is created. So now we can treat this as if it were a table. So I can go to the query window, write select star to select all the columns from the table car, and I also make a new query where I will list everything from the view we just created, sold cars all, so that we can see the difference between these two. I select both and execute so that I can see the result of both. And here we see the table car, which has 6 columns. And here we see our view that have only the 4 columns that we specified when we created the view. When we are creating a view, we are not restricted to only select the columns in the view. We can also select which rows we want to be a part of the view. We're going to write a view that not returns all the sold cars, but only the sold Peugeots. And then we give the view a new name, so we can call it sold cars Peugeot. And we want it to include the same columns as the other view and from the same table. But now we will say that only the rows where the value Peugeot is registered in the column car make shall be part of the view. I go to SQL Server to run this create view statement. I select it and click execute. Completed successfully. I go to views and click F5 to refresh, and then I will see my new view. I write a query to select all the rows in this view to show them, and select it and click execute. And now I see that only the rows with the Peugeots are shown. We can also change a view that we have created. Let's say that we didn't want this column color in this sold cars Peugeot. Then I go to sold cars Peugeot in the Object Explorer. I select it, right click and select design. And then we can see graphical design. We can also see this SQL code down here. And now I can remove color, and I save it and close this one, and if I now select all from the same view and execute it, then I will see that I have in return only the 3 columns car make, reg date and price. So color is now removed. A view definition can also include several tables. And here we see 2 tables. We have this owner table and we have postal address table. And if the one who's querying these tables often need to list all the names, but not only the postal code, but also the city, then they will have to join the 2 tables every time. But instead, we could make a view that includes all these data from this table, and from this other table includes the city. Then we could query this one table only instead of joining these 2 tables. We will create a view to do that, and we call it owner and city. And we select the columns, owner ID, first name, last name, postal address, dot postal code. Here I have a postal code in both the tables, so I need to select the table to reference it, and city. I will get these columns from the 2 tables named owner and postal address. And it will be an equal join based on postal code, which is the foreign key in owner and the primary key in postal address. In another video I showed the 2 different syntaxes to make this equal join, and I have written the second one down here. So alternatively we could say from owner inner join postal address on owner.postal code equals postal address.postal code. You should be familiar with both ways to do it. I go to SQL Server to run the query. I select it and click execute. Completed successfully. I go to views and refresh with F5, and now I can see my new view defined here. I write a query to select all the rows and all the columns in this new view and execute it. Now I can see that I get a list of all the owners and both their postal code and city. Now we want to create a view named the blue car that lists all the columns from the car table where the color equals the value blue. And then we want to make a query where we combine this view with the real table. So the first thing we will do is to go to SQL Server. We will then run the query that creates this view with 4 columns from the table car, and with the condition that specifies that the color have to be blue. So I select it and click execute, and then I can go to views and click F5, and then I will see this new view stored under the folder view. And I run the query to see the content of the table. Click execute, and we see that we have 3 rows with cars, and these are all the blue cars. But if I, in addition to this owner ID, also want to list some more data from this owner table, then I will have to join these 2 in my query. So I need to join a view with a table. And then I can treat the view just as if it had been a table. So I select the columns I want in return, and specify the view and the table to be joined, and I specify the equijoin condition, which is the column owner ID in owner and owner ID in blue car. And I also want to order or sort the result by the column owner ID. Go to SQL Server, and now I want to run both queries. Click execute, and I can see that the join query returns owner ID, last name, reg number and car make for all the blue cars. We can also insert data into a view, and we can update the view, and we can delete data in a view with some restrictions. We will see that what is really happening is that we are not really working on the data in the view, but on the real underlying data. First we will do is to insert some data into the blue car view. Since we will insert into all the columns, we don't need to specify the columns, we only need to specify the values. In SQL Server we will insert this data. I click execute, 1 row's affected, and that sounds fine, but if I select all in this table now, we will see something strange. Execute, and here I have all the instances in the table, and we see that we don't have any reg number like this, even though the insert statement succeeded. And the reason why is that when we specified the blue car view, it was specified so that it had a where condition that would include only the blue cars. And we see that in this view we don't have a color column, so we haven't even got a chance to specify blue as a color. But still this row was inserted, and that means that it was inserted in the real underlying table. So if I now list all the content of the table named car, then I should find it. And here, row 3, we see that the reg number that we inserted, and the color is unknown, and that is because unknown is the default value specified when we made the create table structure for the car table. And the reg data is null because we haven't inserted anything there, so it's only these 4 values we inserted in the underlying table. So this view is only a view into the real table. So when we insert, delete or update, we are inserting, deleting and updating in the real table. I will list the content of blue car again, so I execute this one. I have these 3 rows. We see that the car with this reg number has the price 700,000. Well, in fact it says 7 millions. It wasn't meant to be that, but okay, then we can change it to, for instance, 3 millions. I can use the update command and write update blue car and set price to 3 millions, where reg number equals this one. So I run this query, execute, 1 row's affected, and now I will list the blue car view again. And now I see that this has changed. And if I also list the car table, then it should also have changed here. And I see that in row 2 that it has changed to 3 millions here also, because this is the real underlying data. And we can also delete rows from a view, but remember that it has the same underlying data as the table it is defined from. So if we delete this row, for instance, in blue car, then it will also be deleted in the real underlying table, which is car. So you can try this. I go to SQL Server and we will run this query, execute, and 1 row was affected. So if I now run the select star from blue car, I will only have the 2 other rows left. And I can also select all from car, and I will see that this reg number don't exist in this table anymore, this car table. If you want to delete the entire view, then it's the same way as if we delete the table, where we used drop table and the name of the table. Here we use drop view and the name of the view. We can try that too. Drop view blue car, execute, commands completed successfully. I still see it here, but if I go to views and click the F5 button to refresh, then I see it. Here I have created a view where I have included an aggregate function to calculate the average price. Before this price is calculated, the query will group all the cars by car make, and then it will calculate the average price of each group. I run this query to see the result. Select star from this new query, and here you see that the result is 2 columns, car make and average price. So this is now a view which we can use approximately like a table. But views also have some restrictions, and now we will look at one of them. I will now try to update this view by setting the car make to Opel, where the car make is Peugeot. And we know that we have 3 Peugeots, so now we will have 3 Opels. Now I will run this in SQL Server, execute, and then we will get an error. And it says that cannot update the view or function because it contains aggregates or distinct or group by, etc. And we have both a group by in our query, and we have average in our query. And that means that this view is not updatable. So there are some restrictions on updating views, and here are some of them. Order by cannot be used since views like tables are per definition unordered. So we are not allowed to use order by when we create a view. And when we're using insert, update and delete, only one underlying table must be addressed. And like we saw in the last query, derived columns like average, sum, minimum, maximum, count, etc. are not updatable. And the same applies to results from group by, having or distinct. The view to be updated must also include the primary key to the table that it's based on. And there are also some other restrictions related to joint tables, and these restrictions differ from system to system, but there are good reasons for most of the restrictions. If we, for instance, have calculated an average in a view based on several underlying rows, then if we would be able to change the average without changing the values in the underlying rows, then the average obviously would give a wrong result. So that is, for instance, the reason why this isn't allowed. Like we could create tables with SQL Server's graphical tools, we can also create views in almost the same way. Then we have to right click on views and select new view. Then we can select the tables and columns we want to be included in the view, and the SQL Server will at the same time also generate the SQL code. So if I go to views, right click, new view, just to make an example, I can select these 3 tables, add, close, and I can say that from this one I want reg number and the car make, and from this one I want owner ID, first name, last name, and postal code, and city from this one. And we see that when I select this, the query is created down here. And now I can save it, and I get a chance to give a name, and I call it test, and OK. And I go to views and click the F5 to refresh, and now I see this test view appeared under views.